Hello everyone. So as you can see, it's this time we are talking about the word problems based on time, distance, and speed. There are three different types of word problems. I'm going to focus on two types in this video. The third type I'll take it in the next video. So the first type that I'm talking about is two cars which are moving towards each other, and as first case to get the first equation, and in the second case of the same problem they are moving away from each other. Okay, so there are two cars. Now, if you look at the question, we know they are saying in the question that the two cars A and B, or there are 2 points A and B which are 90 kilometers away. That means something about the distance is mentioned. And then there is something about 9 hours, 9 by 7 hours, so something about time is also given. But nothing about the speed of the cars is being talked about, right? So the first thing that we'll be assuming here is let me make it a little bit bigger so that it's visible. Yeah, so we'll say let the speed of car from A be x kilometer per hour. Okay, and let the speed of car from B be y kilometer per hour. Okay, so we are taking x kilometer and y kilometer. So the distance between the 2 points, the total distance between the 2 points is given as 90 kilometers, right? So let's draw this situation as case 1 and case 2. So case 1, there is a straight path. Okay, there are 2 points A and B. Okay, the total distance from A to B is 90 kilometers. This much is the first part. A car starts from A and another car starts from B. So let's represent the cars by rectangular boxes. Okay, one is starting from A and the other is starting from B. Okay, so they both are moving at the same time. If they go in the same direction, means the first one is going in this direction, means on the right direction. Sorry, if the car A is from A, if the car is moving to the right direction, then from point B also the car is moving to the right direction, right? Now, if they both are moving in the same direction, they are going to meet after 9 hours. So let's say they both are going to meet at some point C. Okay, clear? So there is a car which is starting from A, there is a car which is starting from B. These two cars are going to meet at point C, right? So let's talk about the distance, speed, and time taken for car A. Let me name it as car A and car B because they are starting from positions A and B. Okay, so let's say that I'm going to put it like this. Oh, sorry. Car A, car B. Speed for car A, sorry. Speed for car A which I took was x kilometer per hour. The distance that this person is going to travel is from A to C because he's going to reach till C. So distance is AC. And time taken is, if you can see, they are saying 9 hours, right? So it's 9. Now we know that speed equals to distance upon time, right? So can I say here the speed is x, distance is AC, and time is 9, right? So am I getting 9x is equals to AC, right? Let's talk about the car B. Still I'm not getting the equation. Okay, so speed will be y kilometers per hour. Now for B, it's moving from B to C. So the distance which this car is going to travel, that is car B which I have labeled, is going to be B to C. Again, the time that it's going to take is the same 9 hours. Okay, so here again, speed time multiplied by time is going to be distance. So we'll say 9y equals to BC. Okay, now if you look in the given case which I've drawn, AC is the total. AC is total. Can I say AC is AB plus BC? Again, AC is equals to AB plus BC. So I'm going to say from figure AC is equals to AB plus BC. I can show a rough figure here. This was my A, this is my B, this is my C. This is my car A moving this direction, car B also moving this direction, meeting at C. This is my 90. Okay, so AC we got 9x from the above case. Sorry, right? AB, if you see from the figure, it's 90. And BC, if you see, it's 9y, right? So we are going to substitute this. Again, AC is 9x, AB is 90, and BC is 9y. So I'm going to shift the 9y on the left. So it becomes 9x minus 9y equals to 90. Divide by 9, so x minus y is equals to 10. This is the first equation. Okay. Now case 2. Let's read the question. Case 2 says that the cars are moving in the opposite direction and they are meeting in 9/7 hours. So let's draw the case. So again, the distance between the 2 points A and B is 90. This is A, this is B, the distance is 90. Okay, the car from A is moving towards the right. Then the car from B is moving towards the left, because that's what they're saying. They are moving in the opposite direction, right? So they are going to, let's say, meet at some point D. Okay, so again, we are going to write the cases here for car A and car B. Speed, same x kilometer per hour. Okay, distance, now it's going to be from A to D, and time is 9/7. Same way here, the speed will be y kilometer per hour. Sorry, and distance is what? B to D, BD, and time is 9/7, right? So here distance into, speed into time is distance. So AD distance will be equals to speed into time, so 9x/7. And BD will be equals to, that is distance is equals to speed into time, so 9y/7. Okay, now in the picture, if you see AB, in the middle is D. So AD plus DB is going to give us the AB, right? So we'll say AD plus BD will give us AB, right? AD is 9x/7, plus 9y/7 is BD, and AB is 90. Let's divide by 9 first. So x/7, let me write it again. X/7 plus y/7 is equals to 10. 7 is a common denominator, so multiply throughout. We'll get x plus y equals to 70. This is our second equation from case 2. That was our first equation, where we were saying they were moving in the same direction. It was minus x minus y equals to 10, and in the opposite direction, it's an addition. You're getting x plus y equals to 70. You solve it, you get the answer, and that will be the speed of car A and car B. Okay, let's take 3 more questions of the same type. I'm just giving you a quick hint how to do it. Now, point A and B are apart by how many distance? Yes, by 70. So you will suppose car A speed as x and car B speed as y. So let me take the case 1 and case 2 and quickly give you the hint. Okay, so let's say this is my car A, car B, here also car A, car B. Okay, I need to shift this a little bit there. Okay, so now in the first case, both the cars are moving in the same direction. So this direction. You can read it. And they are going to meet at some point. Okay. Clear? So this is my A, this is my B, and they are going to meet at C. Whereas in this case, they are moving in the opposite direction. They are meeting at some point D. This is A, this is B. This is the case 1, and this is the case 2. Okay. Now, what is the distance between the 2 points A and B? It is 70 kilometers. Right? So that is total distance from here to here is 70. Okay, so car A starts from A, another car starts from B. Simultaneously, if they travel in the same direction, they meet in 7 hours. So let's talk about that. Car A, car B. Already you have to write the sentence. Speed of car A is x kilometers per hour. That is a supposition you have to write as first sentence, which I have not given. You have to write it. Okay, the distance that this car is going to travel is AC. Okay, and time in the first case it's taking is 7 hours, right? So 7. Then speed for car B is going to be y kilometer per hour. Distance is, yes, B to C, and time is going to be 7, same, right? Okay, so distance is equals to speed into time, that we know. So AC is equals to 7 is time, speed is x. And here BC is equals to time is 7, speed is y, right? Now, what is the case? It's going from A to C, right? So from the case 1, we can say A to C is equals to what? AB plus BC. Okay, so that is what we are going to write. AC is equals to AB plus BC. AC is 7x, AB was 70 kilometers, and BC is 7y. Shifted to the other side, so 7x minus 7y equals to 70. X minus y equals to 10. That's the first equation, right? Let's talk about the second part. So again, I'll be taking two cars, car A, car B. Speed is x kilometer for A. For B, the speed is y kilometer per hour. Sorry. Distance in this case, the car A is going from A to D, and car B is going from B to D, right? The time we need to read the question, okay? Because the second part I have not read. So if they are traveling towards each other, they meet in 1 hour. So the time is 1 hour. Okay. So again, the speed multiplied by time will give me a distance. So distance AD is equals to 1 multiplied by x, so x, and distance BD is equals to 1 multiplied by y is y, right? So now in this case, we have AD plus DB is equals to AB. So AD plus DB is equals to AB. So which is x plus y equals to 70. So I got my second equation. You do your elimination and you'll get the equation. Correct? Got the hint? The remaining two questions, this one. So now here, the only thing that I want to help you out is this 1 hour 20 minutes. So 1 hour 20 minutes, you can change the minutes into hours as 1 hour is plus 20 minutes. So in 1 minute, in 1 hour, how many minutes? 60 minutes. So 20 by 60, which is 1 plus 2 by 6, which will be 1 plus 1 by 3, which is 4 by 3 hours. This will be the time in case 2, okay? 4 by 3 hours. Clear? And this is your next question. This is the fourth question. Okay? And this is the third question. Clear? 80 kilometers apart, moving in the same direction. 8 hours later, they'll meet. In the opposite direction, they'll meet in 4 by 3 hours. Okay? And in the next case, 100 kilometers apart, moving in the same direction, they'll meet in 5 hours. And in opposite direction, they'll meet in 1 hour. Hope this is clear. Thank you.